Hello and welcome to Chapter 8, Section 7, which is solving one-step inequalities. This starts on textbook page 635 and goes through textbook page 638. And my cute little note here says, don't forget to write everything. That means even the stuff that you see in the book. So you're looking for this baseball batter here with the baseball with wings on it on textbook page 635. Under the real world link, it says, the graph shows the number of home runs that the total hitters on the baseball team hit last season. Write an inequality that compares the number of home runs Nate hit, so we're going to go ahead and underline Nate, to the number of home runs Josh hit. So then let's go ahead and change colors here. So we have Josh. Actually, let me just, this is Josh. And then we have Nate. And you can tell that on the left, it's got the alligator mouth or symbol open for the greater than sign. So we need to look and see which one had the greater number of hits. So we can see that Nate did. All right, so as you can see, Nate hit 15 home runs. So we're going to go ahead and put a 15 here because 15 is greater than what Josh hit, which looks like about 12. Next it says, I'm going to go ahead and erase this part right here. Next it says, actually no, sorry. Let's go ahead and do that. We're going to erase this part. Next it says to write an inequality that compares the number of home runs James hit, so James, to the number of home runs Mark hit. And the one on the left has to be the one that's left. So James and Mark. And obviously James is less than, so we need to look and count and see on the graph what he has, which looks like about 19. So 19 is less than what Mark hit, which looks like about 22 or 23, so we're going to put that as 23. Okay, and on the last one, let's go ahead and erase what we've done up here. And then on the last one, it says, suppose James and Mark each hit 3 more home runs, okay? So that means that James would be at 20, 21, 22, and Mark would be at 24, 25, 26, okay? Write a new inequality that compares the number of home runs James and Mark hit. So notice the one on the left has to be the one that's less than. So James is still less than. So 22 is less than 26. Now you're looking at the top of textbook page 636 where you see use addition and subtraction properties to solve inequalities. And you have a close-up look here. All right, so at the top it says, when you add or subtract, so we're looking at adding and subtracting here. When you add or subtract the same number from each side of an inequality, the inequality remains true. So what this is basically saying is just like we could do the inverse operation with equations, we can treat inequalities the same way. So in this first example, we've got 5 is less than 9, and what they've done is they've added 4. And all this property is saying is as long as you do the same thing to both sides, the inequality remains true. So 5 plus 4 is 9. And your less than sign stays the same, and 9 plus 4 is 13. So 9 is still less than 13 because we did the same to both sides. And then on this next problem, we have 11 is greater than 6, which is true. And then it says we're going to subtract 3, but notice we subtract 3 from both sides. 11, 10, 9, 8. So we have 8 here is greater than 6 minus 3 is 3. So notice that inequality is still true. Number 1, example 1 says x plus 7. So let's go ahead and write this off to the side here. X plus 7 is greater than or equal to 10. And actually, let me go back one slide. There is something of note here that I forgot to point out. It says these properties are also true for the greater than or equal to and less than or equal to symbols. So you want to make sure that you understand that it applies to those as well. All right, so now the problem that we have, they have now said subtract 7 from both sides. And the reason we're subtracting 7 from both sides is because of this plus 7 here. Remember, we look to see which number or what numbers, what's being done to the variable. So the variable in this problem is x. What's being done to the variable is we are adding 7 to the variable. So in order to do the inverse of that, we are going to need to subtract 7. And we can't just subtract 7 from one side, we have to subtract it from both sides. So I should see you cross through that. And again, you should have written this all over again. I should see you cross through that. And then here I want to see 10 minus 7 is 3. And then I need to see your brand new inequality, which is x, because see, you still have that x left over here. is greater than or equal to, we got that from right here, and 3 is the number that we got from the subtracting. So our final answer here is x is all of the numbers that are greater than or equal to 3. Then to graph that, we are going to look for 3, put a dot on it. We're going to close that dot because of this little equal sign here on the sign, and then we're going to say which number makes this true, 4 or 2? Well, 4 is greater than 3, so that's why it goes to the right. For the next problem, you see x minus 3 is less than 9. So again, we need to identify the variable. The variable in this problem is x. Then we need to say what's being done to x. Well, x minus 3. We're subtracting 3 from x. So the inverse of that is going to be to add 3. And remember, we do that to both sides because what we do to one side, we do to the other. So we're going to cross through this, and then 9 plus 3 is going to be 10, 11, 12. And so now we're going to rewrite what we have left. So we have x left here is less than 12. So now we're going to look for 12 on our number line. It's going to be an open circle because remember there's no line underneath that less than sign. And we need to think the number 11 makes that true. So we're going to go ahead and turn that, we're going to go ahead and move that arrow to the left. All right, so you want to pause the video here and you want to check and see if you can do it on your own now. All right, so here for A, you see n plus 2 is less than or equal to 5. So the variable is n, we identify that. What's being done to n? 2 is being added to it. So the opposite or inverse is to subtract 2, and we make sure we do that to both sides. We're going to cross through that, and then 5 minus 2 is 3. So now we rewrite what we have left. We have n left on this side, less than or equal to 3. So we're going to write an open dot first, then we're going to close that dot because of the equal sign, and my dot's a little crazy big here and not in red, so open dot, then we're going to close it because of that equal sign. And then we need to think about which direction, what numbers are less than or equal to 3. Oops, one second. There we go. Less than or equal to 3. Okay, well 2, 1, 0, those are all less than or equal to 3. So we're going to draw our arrow in that direction. All right, on problem B here, you should have written y minus 3 is greater than 9. Then identified the variable is y. So we're going to add 3 to both sides because 3 is being subtracted first. 9, 10, 11, 12. So now we get y is all the numbers that are greater than 12. So we're going to locate 12 on our number line here. And we're going to do an open circle. We're going to keep it an open circle because there's no line under that. We're going to keep it an open circle because there's no line under the greater than sign. And then we are going to look and see which number, 13 or 11, which one is greater than 12? Well, 13 is, so that means we're going to draw our line going to the right. All right, so right here I have a special note. I do want you to write special note and then the problem I'm giving you here. I wanted to make sure to mention that there are times in inequalities and in equations when you're going to find the variable on the right-hand side of the sign and not just on the left. So let's talk about for just a second and see how we would solve these problems. Well, first things first, you still identify the variable. And in this problem, the variable is x, which you see right there. You still look to see what's being done to the variable. Well, you can see that we are adding 3 to the variable. So even though the 8 is on the left, which is the side we normally work with, that 8 isn't what's important to us right now. We always have to find the variable and then what's being done to it. So I've identified that 3 is being added to it, so that means we need to subtract 3 from both sides. So let's go ahead and do that now. 8, and so we have 5 over here. So now we have to write down what we have left, which is 5 is less than or equal to x. Now this becomes kind of a tricky situation because when you go to plot a line or plot this on a number line, you have to plot x. We're not plotting necessarily the 5. We need to know what x is, not what 5 is, if that makes sense. So the first thing I'm going to do, I do know that I'm going to have 5 here, 4, 3, 2, and we'll just, actually, I'll keep it. There we go. And then 6, 7, 8. So when I create my number line, I always just have those 2. So before I plot my number line, though, I need to think about something. When you're reading this, you need to read from the variable. So if this was, let's say, for example, x is greater than 2, then you could say x is greater than 2. But because this reads 5 first, you want to read from the x, which is right here. And if you look, x has the mouth open to it. So that means that x is actually greater than or equal to 5. So you can rewrite the problem, which is x is greater than or equal to 5. So whenever you have to switch the variable back to the other side, you also have to switch the sign around, because really what you're doing is you're just bringing the sign with you so that it says the same thing. So now you can go ahead and plot this and say, okay, x is all the numbers that are greater than or equal to, so it's going to be a closed dot, and it's all the numbers that are going to be to the right, because 6, 7, and 8 are all greater than or equal to. Let's try one more with that same concept. Okay, the problem you see here is 6 is greater than or equal to x divided by 2. So let's go ahead and start with what we normally start with. What's the variable? The variable in this problem is x. What's being done to the variable? Well, we're dividing x by 2. So remember, the inverse operation for dividing is multiplication. So that means we're going to multiply both sides by 2 to get rid of the division by 2. So let's go ahead and cross simplify those out. Then on this side, we are now going to be left with 6 times 2, which is 12, is greater than or equal to x, because everything else is gone on that side. Again, we still have the same issue. Let's go ahead and draw our number line. Let's put 12 in the middle, 11, 10, 9, and then let's put 13, 14, 15. All right, so we know that our sign is going, or our dot is going to go on the 12, but what's difficult is when we go to graph it. Remember, we have to read from the x. So what we're actually reading here, see this x right here, so we're going to rewrite it as x, but notice how the sign is pointing away from. The gator mouth is open to the 12, not the x. So when you rewrite it from the term of x, you want to make sure that that sign, the gator mouth, is still not open to the x, it's open to the 12. So it's going to be less than or equal to 12. So now what we're going to do is go ahead and plot that. We're going to do an open dot first, then we're going to close it because of that line underneath the less than sign. Then we're going to say, okay, is 11 less than 12 or is 13 less than 12? Well, obviously 11 is less than 12, so that means that all of the numbers that make the solution correct, or all the solutions for this inequality, are to the left. All right, go ahead and take a look on textbook page 637. It says use multiplication and division properties to solve inequalities. All right, it says use multiplication and division properties to solve inequalities. When you multiply or divide each side of an equality by the same positive number, the inequality remains the same. Now, we haven't worked with integers yet, but the positive number is just saying you can't multiply by negative signs currently. So let's go ahead and look at these examples here. We've got 5 is less than 10, so we could multiply both sides by 2, as they've done here. Now we have 10 on this side is less than 20 on this side. Stays the same. Same thing over here. 16 is greater than 12. We are going to divide both sides by 2. Divide by 2, divide by 2. We get 8 is greater than 6. Still also a true inequality. And it says these properties are also true for the greater than or equal to and less than or equal to signs. Example 3 here says solve 5x is less than or equal to 45. So 5x is less than or equal to 45. I need you to go ahead and write that off to the side where you can find some blank space. And then you need to think, okay, first, what's our variable? Our variable is x right here. And then what's being done to that x? Well, it's being multiplied by 5 because there are no spaces or signs in between 5 and x. So that means in order to perform the inverse operation, you have to divide both sides by 5. So now that will get rid of that. You are left with only x on this side is less than or equal to, and 45 divided by 5 is 9. So now you have your inequality solved. You need to graph the inequality, so we're going to put 9 right in the middle. I realize there's a graph already there. I need you to do it anyway. 8, 7, 6, 10, 11, 12. So each time I make a graph, I always do the number in the middle and then 3 numbers on each side. So now we're going to go ahead and look. So so the dot's going to go on the 9 first. Then it's going to be a closed dot because there's a line underneath it right here. That line is what tells us to close the dot. X is going to be less than or equal to 9. So 8 actually makes that true because 8 is less than fine. So let's go ahead and point our arrow in that direction. All right, let's look at example 4. It says solve x divided by 8 is greater than 3. So just like we did in that example before, let's go ahead and look and see, well, x is our variable. We see that right here. X is being divided by 8. So in order to get rid of dividing 8, we need to actually multiply each side by 8. So we're going to go ahead and do that now. Cross those out. And we're left with x on this side, because those 8's got crossed out, is greater than 3 times 8 is 24. So now, as you can see, we're going to go ahead and plot 24 in the middle, 23, 22, I knew I was going to run out of space, 21, 25, 26, and 27. All right, so now we're going to go, okay, x is greater than 24, so it's going to be an open dot. It's going to stay an open dot because it doesn't include 24 as a solution. And then it's going to be all the numbers to the right on the number line because x has to be all the numbers that are greater, and 25 is greater, not 23. If you think you have it, let's go ahead and try some on your own. Go ahead and pause the video now and work through the problem. All right, so now you see for C that 10x is less than 80. So let's go ahead and think. First, we identify the variable. It's x. What's being done to x? We're multiplying it by 10. So let's go ahead and do the inverse, which is to divide by 10. So we're going to divide both sides by 10. Now that goes away, and we are left with x on this side is less than 80 divided by 10 is going to leave us with 8. So now we are going to, because basically those go away, you're left with 8 over 1. So now you're going to plot it on your number line here, and you've got 8 here. Remember, it's not less than or equal to, it's just less than. And so the arrow is going to go in this direction because it's all the numbers that are less than 8. So on the line over here, you're also going to write x is less than 8. All right, so for D, we've got x divided by 6 is greater than or equal to 7. So again, first, our variable is x. X is being divided by 6, so the inverse of that is to multiply by 6. So we're going to multiply both sides by 6. Cross simplify that. We're left with x is greater than or equal to 42. So now we're going to write that on our answer line here. X is greater than or equal to 42. Then we're going to look on our number line. We're going to first start with an open circle. We're going to go, okay, yep, there's a line under there, so we need to make sure to close that circle up because it includes 42. And remember, x is all the numbers that are greater than or equal to 42, so that means that our line needs to go to the right. All right, it says you can check your solutions by substituting numbers into the inequality and testing to verify that it holds true. So for this example, let's go ahead and quickly solve it. We multiply by 7. I believe that's the one we just did. And we're left with x equals 42. I'm sorry. Whoops. There we go. X. Oh, I messed that up. Okay, here we go. Greater than. So let's say that x is greater than 42 for this particular example. Let me just make sure it matches up with that one. Greater than or equal to. Perfect. Okay, so now what it's saying is you want to take the original equation, which was x divided by 7 is greater than or equal to 6, and you want to plug in any number that's greater than or equal to 42. So why don't we just plug in 42 to see if that works? So 42 divided by 7 is greater than or equal to 6. 6 is greater than or equal to 6. Yes, it is. So that's what they mean by checking your solution. Now you're on textbook page 638. You want to take a look at example 5. Example 5 says, Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. So now you know the $42 has to be by itself because that's the total. Remember when we were writing equations before, it's the same for inequalities. So she does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. So if she's got 7 friends, that's where we get the 7. C is going to represent the cost of each bag. Okay, we're going to write that out to the side. And remember, so the total for 7 friends times the cost of each bag has to be less than or equal to $42, which is on the right. So that's the first part of this problem. The second part then is to solve it. So now we've got, so let's put a box around that. Start with 7C is less than or equal to 42 again. Divide each side by 7. And we get C. is less than or equal to $6. So she can spend $6, a maximum of $6 on each party favor bag. All right, great. Now you can go ahead and get started. For your homework, I would like you to do numbers 1 through 5. Please make sure that you're showing your work out here, down here to the side. So you want to start with the original inequality and then show me the inverse operation and how you solved it. Up here, you're going to first have to write an inequality. So you have to come up with the inequality first, then show me how to solve it, but you don't need to graph on 3 and 4. And then 5, I do want you to answer as well. Good luck, and I will see you next class period.